For years, the story in AI has been pretty simple. Bigger is always better. But what if that's all wrong? A really fascinating argument from researchers at NVIDIA and Georgia Tech suggests the future of AI agents, the tools that are going to automate our digital world, isn't about scaling up, but about scaling down.
The whole argument really kicks off with a number that's, well, it's kind of hard to ignore. In 2024, $57 billion was poured into the cloud infrastructure needed to run today's giant AI models. That is a massive, massive bet on one specific vision for the future of AI.
But here's the catch. The actual market for the AI services running on top of all that hardware? Just $5.6 billion. That's a 10x mismatch, right? When what you're spending is 10 times bigger than what you're making, you gotta ask, is this sustainable?
And this economic paradox points to a pretty fundamental problem. We might be using the wrong tools for the job. We've built these incredibly powerful generalist models, but then we use them for super simple, repetitive tasks. It's the very definition of overkill. It's like using a supercomputer to run a pocket calculator.
So if these giant models are the problem, then what's the solution? Well, the answer they propose is a really powerful alternative, small language models, or as we'll call them, SLMs. So what exactly is a small model? What's cool about this definition is that it isn't about all the technical jargon or parameter counts. It's actually refreshingly practical. An SLM is basically a model that can run efficiently on a device you already own, like your phone or your laptop, without any annoying lag. The whole focus shifts from just raw power to real-world practical performance.
And this gets us to the core difference in philosophy. Think of a big, large language model like a conversational Swiss Army knife. It's super versatile, sure, but it's not always the best tool for every job. An SLM, on the other hand, is like a surgeon's scalpel. It's precisely designed for one specific set of tasks. And for the vast majority of what AI agents actually do, you don't need the big, clunky knife, you need the scalpel.
But is smaller really smarter? The case for these models, it turns out, goes way beyond just saving a buck. It's about building systems that are fundamentally more effective and, dare I say, more intelligent.
The whole argument really rests on three foundational pillars. The first is that SLMs are powerful enough for the job. Second, that they're operationally a much better fit. And third, that they are, in the end, economically necessary. So let's look at the evidence for each one. First up, are they powerful enough? Oh, absolutely. We're not talking about using weak, dumbed-down models here. Modern SLMs are punching way, way above their weight class. A model like Microsoft's Phi 3, which has 7 billion parameters, performs like models 10 times its size. And maybe even more impressively, some highly specialized SLMs are actually outperforming giants like GPT-4o on very specific tasks.
Second, they're just a better fit for the job, operationally speaking. This gets to the reality of what AI agents do all day. Most of them aren't having deep philosophical debates. They're just executing narrow, repetitive jobs. Extracting a piece of data, formatting a response, calling another tool. And for that kind of work, you want a specialist, not a generalist. And third, the economics are just undeniable. SLMs are 10 to 30 times more efficient, both in cost and in speed. But the real game changer here might be the agility. You can fine-tune an SLM for a new task in a matter of hours, not the weeks it can take to retrain a massive model.
So, let's be clear. This isn't about getting rid of the big models entirely. The most powerful idea in this whole paper is about combining the best of both worlds, building smarter hybrid systems. And here's what that looks like. The system on the left is the old way, one giant, expensive model trying to do every single little thing. But on the right, you see a much smarter design. A controller model acts like a manager or a dispatcher. It gets a task, and instead of doing all the work itself, it routes it to the right specialist. A cheap, fast SLM for simple jobs and only calling on the expensive LLM when its unique power is truly needed.
And this creates what the paper calls a Lego-like way of building AI. Instead of trying to carve everything from one giant block of marble, you're building with small, specialized bricks. You can scale your system by just adding new experts, creating something that's cheaper, faster, and way easier to manage. This vision is super compelling. But how do you actually build it? Well, the paper provides a really practical roadmap for pretty much any organization to start making this shift right now.
They actually outline this clear 6-step conversion process. You start by just logging your AI agent's activity to figure out the most common, repetitive tasks. From there, you can pick a good candidate SLM, fine-tune it just on that task, and then swap it in, systematically replacing expensive calls with cheap, efficient ones.
And the potential here is just massive. An analysis of popular AI agents found that up to 70% of the queries they currently send to large models could be replaced by a specialized SLM, like today. That is a huge untapped opportunity for immediate improvements in both cost and speed.
So what's the big takeaway from all this? This isn't just some minor technical tweak. It's a strategic shift for the entire AI industry. It points to a future where AI is more democratized, more accessible, more affordable for everyone, and ultimately on a much more sustainable path forward.
And this leaves us with a really provocative question that kind of reframes the entire quest for advanced AI. Are we trying to build one single giant all-knowing brain? Or is the real path forward to create a diverse, efficient, and collaborative society of specialized minds? The answer? Well, it's going to define the next decade of technology.